to another WJEC A level physics question. This is question 6 from January 2012's PH4 paper. It's on simple harmonic motion, which nowadays you'll find in Unit 3. What we got is a question about a poorly designed bridge that oscillates up and down with a natural period of 0.81 seconds. And there's a dog on the bridge that we'll come back to a little bit later on. Got to calculate first of all the natural frequency of the oscillation. Well, there's a very basic relationship that frequency is 1 over period. So we got 1 over 0.81, giving us an answer of 1.23 Hertz. Next we've got to show that the angular velocity of the oscillations is approximately 7.8 radians per second. So here we can simply use omega is 2 pi over t given in the data book. So it's 2 pi over the period of 0.81, and that will actually give us an answer of 7.76 radians per second. Next it tells us when people walk across this bridge, oscillations of large amplitude can occur, and we've got to explain the cause of the large amplitude oscillations and their possible consequences. Well, this is basically resonance. So what will happen is something like if people walk at the same frequency as the natural frequency, and that's the important bit, then resonance will occur. So that's the resonance there, is those large amplitude oscillations caused by the driving force, the marching of the people across the bridge, matching up with the natural frequency of oscillation. And the possible consequences is basically that the bridge could get damaged, or something like maybe the poor old dog on the bridge will get thrown off the bridge there. For part D, a dog standing in the middle of the bridge moves up and down with simple harmonic motion with an amplitude of 10.4 centimeters and a period of 0.81 seconds. At time t equals 0, the dog is at the center of its motion moving upwards, and we've got to calculate the displacement of the dog at t equals 1.40 seconds. In the data book, we have the equation x equals a cos of omega t plus epsilon. But we rarely use that in equations. What we do instead is think about the actual setup of the oscillations here, and we can simplify that in most cases to either sine or cos. Now the key here is that t equals 0, the dog is at the center of its motion and moving upwards. So that expression can simplify to x equals a sine omega t. If you think about the shape of a sine curve, starts at 0 and then increases. What we're trying to do here is find that displacement, so we're going to fill in the values. We can leave the amplitude as 10.4 centimeters so long as we remember to give the answer in centimeters. Omega was 7.76 and t is 1.4 seconds. Now a really important point here is to make sure that your calculator is in radians mode and not in degrees mode, or you will end up with an incorrect answer. So putting that in, we will get minus 10.3 centimeters. So in other words, the dog is below its equilibrium position at that time. Next, the amplitude of oscillation is increased and is now so great that the dog temporarily loses contact with the bridge, and the displacement of the bridge where the dog is standing is given in the graph. And we've got to calculate the dog's displacement when it loses contact with the bridge, with the hint that the downward acceleration of the dog cannot be greater than g. So if the dog's acceleration is downwards, that means it has an upward displacement. And the equation that relates acceleration and displacement is the one coming from the definition of SHM, that a is equal to minus omega squared x. Well, since we know that the displacement is going to be negative, we can ignore the minus sign and rearrange this to give x equals a over omega squared. The acceleration cannot be greater than g, so we're going to place the acceleration of 9.81, and we're going to put 7.76 for omega squared to give us a displacement. One second, put that into the calculator, of 0.163 meters, or basically 16.3 centimeters. Without further calculation, we've got to indicate on the graph above the point at which the dog loses contact with the bridge. Well, that's going to be when it's got first has a positive displacement of about 16 centimeters. So 16 centimeters would be about there. That's about 0.12 seconds. The dog will gain contact with the bridge again when its acceleration becomes, or rather when the acceleration of the bridge becomes less than g. And that's going to happen at about 0.28. So we're looking at about there, or possibly just after, because remember the dog is going to have to sort of catch back up to the bridge there. So loses contact here, regains contact there. Thank you very much for listening. Please remember to like and subscribe, and feel free to leave any comments. Goodbye.